So here we're asked to consider the curve y equals some function of x, and we're asked to find the stationary points and show whether these are maximum or minimum points using that second derivative test. So what I'm going to start with is taking the derivative of our function with respect to x, because what we know is that the gradient, or the first derivative of our function, is going to be equal to 0 wherever you have a stationary point. So let's write out our equation. And the first derivative. So this is an easy one, it's just polynomials. So 3 times the 1 out the front leaves us with 3. And taking 1 off the power, that's going to go to 2. We've got 2 times negative 1.5, which is negative 3. X, take 1 off the power, that's going to go to 1, so I'll just leave it. This is like x to the 1, so 1 times negative 6 is negative 6. Take 1 off the power, x to the power of 0 is 1, so we'll just leave it as 6. And we know the derivative of a constant is equal to 0. So that there is the first derivative, or the equation that describes the gradient of this other one up the top. So we said that y dash, or the gradient, is equal to 0 wherever we have a stationary point. So let's solve this equation when y dash is equal to 0. Alright, so we can see we have a quadratic equation, so there's a couple of different approaches that we can take for solving it. One would be to use the quadratic formula. The other approach would be just to find the factors and split your middle term. And that's the approach that I'm going to take now. So what we need is something that multiplies 3 times negative 6, so to give negative 18. And we need them to add to give to negative 3, the middle term. Alright, so the factors that produce negative 18, well, we could have 1 and 18, we could have 2 and 9, 3 and 6. I think that's all the options. So what we need is these to add to give negative 3. So I think looking through this is going to be the one that we want to use, because if we have a positive 3 and we make this a negative 6, they're going to multiply to give negative 18, but 3 take 6 leaves us with negative 3. I don't think we can do that with either of the other two. So that's the one I'm going to pick. So splitting the middle term according to this, we're going to have plus 3x minus 6x, which is the same as what we had on the previous line. Now we need to factorize it, so the common factor between these two is going to be 3x, that's x plus 1, and then I'm going to make this minus 6, common factor, and this can be factorized to x plus 1 as well. So this leaves us with us being able to write 2 brackets, so x plus 1, that's the same across both, bring it out the front, and then everything else is going to form that second bracket. Alright, so we have 2 solutions here. So the first solution is going to happen when x plus 1 is equal to 0. And the second solution is going to be when 3x minus 6 is equal to 0. So rearranging, we're going to get x is negative 1. Here this is going to go to 3x equals 6, or x is equal to 2. So 2 locations for our stationary points. Alright, so the next thing I'm going to go for is the y values that correspond to each of these x's. So we have our equation for y, that was this first one we wrote out. So all we need to do is substitute in our values for x into this equation. Alright, so if we start with this one here, so we're going to get y equals negative 1 cubed, 1.5 times negative 1 squared, 6 times negative 1 plus 9. Might just move this all over. Alright, so solving for this, we've got negative 1 times negative 1, which gives us positive 1, and then positive 1 times the third negative 1 is going to leave us with negative 1 overall. We've then got negative 1.5, I can probably do this in my head. Negative 1 times negative 1 is positive 1, so 1 times negative 1.5 is just going to leave us with negative 1.5. This is going to go to positive 6, and then we have positive 9 on the end. put all of this together, I think it comes out to 12.5. All right, so that means that the coordinate of one of our stationary points is so -1, 12.5. All right, so let's go through and repeat for x is equal to 2. So substituting into that equation for y. All right, so 2 times 2 is 4, times 2 is 8. We've got 1.5 times 2 times 2, so that's 4. So 1.5 times 4 is 6. That goes in here. Minus 12 plus 9. So all of that together comes out to -1. So that means we have our second stationary point figured out. X is 2, y is equal to -1. All right, so that's one part of the answer completed. So the other part was figuring out whether these were maximum or minimum points, and we were told to use the second derivative test. So to use the second derivative test, what we need to get out is our second derivative, so y double dash. So we should be able to look at y dash. Let me bring that up. Let's do it over here, y double dash. So 2 times 3 is going to leave us with 6. Take 1 off the power, that's going to leave us with x. And then this one, we have 1 times -3, which is -3. This goes x to the 0, so I leave it, and the derivative of a constant goes to 0. So the second derivative is 6x take 3. And now we need to substitute in our x values to find out whether this second derivative is positive or negative, because that's going to tell us whether it's a maximum or a minimum. So let's start with x is equal to -1. So this is going to leave us with -6 minus 3, which is -9. And what we know is that if we end up with a negative value for our y double dash, that corresponds to a maximum point when we plot the graph. So now if we do the same thing for the other point, so it's 6 times the x value, so 6 times 2 minus 3. That's going to be 12 minus 3, which is equal to 9. So we've kind of got the opposite here. So if a negative is a maximum, that means that a positive is a minimum. Minimum. All right, so that's the other part of the conclusion. So I might actually pop it here. So this point corresponds to the maximum, and this one corresponds to a local minimum. So let's now just quickly draw a graph, although it didn't ask us. This is just to verify that the answers we've got kind of make sense. So if I plot out here, this is x and y. So -1, 12.5. So let's say this is -1, this is 12.5. That's going to be a stationary point. And then we've got 2, -1. Not very to scale, but we'll say that's there. So if this one is equal to a maximum, then what we would expect is it to look like this. And if this one's a minimum, all right, then we'd expect it to kind of look like this, all right, bottom out there. Since it's a cubic, you can kind of figure out what the rest of it looks like. All right, and that's going to be, our cubic function. So that all looks good, and you can see that these are the stationary points because our function, I should say, it approaches this point and it completely turns around. All right, the gradient here, if we draw it in, should be equal to 0, which is why we set y dash to be equal to 0. So that's all there is for this video, and I'll see you in another one.